Okay, first we're going to determine the domains of f and g. And if you look, the domain of f of g, we're thinking about the denominator. We cannot have x equal to 4, so we'd say, well, I guess if we did it this way, we'd say everything from negative infinity up to but not including 4, and not including 4 and on up. We could do this different ways, but there's one way. And then the domain for g of x would be anything you want. All real numbers. Another way of saying that might be just like that. Okay, so find any vertical asymptotes. All right, well, we know one vertical asymptote for f. That would be x is equal to 4. We noticed that that's not something that's okay. X can't be 4. That would be 0. There are no radicals, so I don't have to worry about that. And for g of x, it's wide open. I don't have any restriction at all. And then let's see, wholes. Wholes would imply that I factored something, so I'd say x plus 4 and x minus 4 for the top. And then I'd say x minus 4 on the bottom, and I'd say, hey, wait a minute. Something happened here that I don't appreciate. This canceled. So I'm going to go back and say, no, I'm going to say this is a whole. Okay, if it cancels, then it's a whole. A whole for the function of x happens at x equals negative 4. Because positive 4, sorry. Positive 4. Because I can cancel that situation out. So since I can cancel it out, that means it's not a vertical asymptote, it's just a whole. And in regards to part E, the difference is not shown in the graphs because technology has a little trouble. Sometimes if you put a table up in the graphing utility, it'll explain, oh yeah, it's undefined here, but it's hard to tell by looking at the graph on a calculator or on Desmos that there's a problem at that spot. You kind of have to know it's there. And then let's see, we're going to complete the table because that takes care of our asymptotes and wholes. That's the only thing going on. There are no vertical asymptotes. Let's see. The degree of the top is 1 degree more. So I guess I should talk about my slant asymptote. They talked about, did they ask me for that? Any vertical asymptotes and wholes. Well, they didn't ask me for a slant asymptote. I know it's there. I guess I'm not graphing this. But I am aware it's there. And if I wanted to find it, I would do this. Okay? And I guess I will real quick. It's x squared minus 4x. So I'd say plus 4x minus 16, and then it'd be plus 4, right? And yeah, if I do that, then I get my 4x and my negative 16. And okay, so it's x plus 4 is my slant asymptote, in case they wanted to know that, but it doesn't say to find that, so okay, fine. So let's see. We're going to use a graphing utility to graph eventually, but first we're going to complete the table. And I went ahead and typed it in my TI Inspire. I defined a function, and then I graphed it, and I created a table in the graphing by saying Control T. And it told me what the values of each one were. For 1, it's 1. I'm not sure if I believe that suddenly. Let's see. Yeah, I don't believe that, and rightfully so. I was looking at the wrong table. So it's 5, and when it's 2, it's 6, and when it's 3, it's 7, and when it's 4, oh, there's the trouble spot. It can't be 4, so it's undefined. So, what can we say there? We'll just say undefined. And for 5, it's 9. And for 6 it's 10, and for 7 you'll never guess, it's 11. Okay, and then I'm just going to add 1. I'm going to add 4 to whatever I have here, and you'll see, it's pretty close. I'm adding 2, so I get 6. I'm adding 3, so I get 7. I'm adding 4, and I'm allowed to be 8 there. And so the only difference is that g of x is allowed to be 4. It's allowed to have 4 as an input, whereas f of x is not. Okay, so go ahead and graph on your utility, on your calculator or on Desmos, and compare. And think about the slant asymptote, and think about where the hole is and that kind of thing.